Welcome to our universe. What you just witnessed was the birth of our universe, dating back almost 14 billion years ago, in an event commonly referred to as the Big Bang. And what you're looking at right now is the edge of what humans can see. It's called the cosmic microwave background radiation. It's the heat left over from the birth of our universe. But where are we? Can you see me? You can find me inside the universe, of course. To find our home, we have to travel far, through galactic clusters and open voids. Passing this local group of galaxies, we see a majestic galaxy with beautiful spiral arms. This is the Milky Way, a name derived by the way ancient civilizations viewed our galaxy from back at home, like a river of milk that spanned across the night sky. But in fact, the Milky Way galaxy is made up of hundreds of billions of stars. But there's only one star that is special to us, the Sun. And around that star we will find our home. The astronomer Carl Sagan described it as the pale blue dot, the only home we've ever known. Our home we call Earth. If you would like to come explore the universe with me, you can find me at the Winery University Observatory atop of Kirkbride Hall in the city of Chester, Pennsylvania. There it is. You found it. Just circle around to try to get a closer look. You can see the dome on top of our building that houses our telescope. You'll have to enter through our main doors. The door straight ahead. You can take the elevator or take the stairs. You'll have to go to the 5th floor. I'll see you up there. Welcome to the Winery University Astronomical Observatory. My name is John Conti and I'm one of the local astronomers here. At Winery Observatory, we are dedicated to enriching the lives of our students and community by making astronomy accessible through our great facility. This observatory was funded by a NASA grant and first opened in January of 2005. Since then, we have opened our doors to the public every week to take a look through our state-of-the-art telescopes. Our facility consists of our main telescope, a 16-inch reflector which uses mirrors, as well as our smaller refractor scope which uses lenses and gives our viewers a wider field of view. Thanks to Sir Isaac Newton, his invention of the reflecting telescope would forever change the way astronomers gaze into the night sky. Just 60 years earlier in 1609, Galileo Galilei constructed his own version of the refracting telescope, which had just been invented a year prior as a tool for seafaring navigators. But Galileo would be the first to use his telescope to look out beyond the reaches of what the human eyes could see. His observations would help support a 100-year-old theory that was still highly controversial and sacrilegious, opposing the established doctrine of the religious authority of the time. Believe it or not, for centuries, people believed that the Earth was the center of everything, and that the objects in the sky circled the Earth. But because of a man named Nicholas Copernicus, our view of the world would soon change. In the early 1500s, Copernicus suggested that it was the sun that was at the center of it all, not the Earth. So to say that the sun is the center of the solar system is a common fact nowadays. But to suggest that in the time of Galileo and Copernicus could have gotten you killed. Copernicus thought he could better explain the motion of planets that were seen to zigzag across the sky, what's referred to as retrograde motion, if the planets were moving around the sun. The pre-existing model, known as the geocentric model or Earth-centered model, explained retrograde motion using epicycles or circles orbiting circles. But under Copernicus's heliocentric or sun-centered model, the complicated epicycles disappeared and a new order was discovered. So there, orbiting the sun, we find the Earth, just one of a number of planets in our solar system. But why do all of these planets go around the sun? It would take another 100 years after the heliocentric proposal to begin defining the mechanics of planetary motion. Tycho Brahe opened his state-of-the-art facility to Johannes Kepler, who mathematically determined 3 laws that were based purely off of real astronomical measurements. About 100 years after that, Sir Isaac Newton would explain that Kepler's laws are a result of more fundamental laws of motion. So let me give you a summary of Kepler's 3 laws. The first law is the law of orbits, which says that all the planets move in elliptical orbits with the sun at a focus. So rather than moving in perfect circles, they move in these ellipses. And the sun is in dead center. It's at this location that we call focus, and that puts the planet sometimes a little bit further away and sometimes a little closer. The second law is called the law of equal areas, and that says that the planets sweep out equal areas in equal times. So because this area we can show as a long thin slice, it doesn't cover as much distance as it does here. And so here, where the planet is furthest from the sun, it will actually move slower, and as it approaches the sun, get faster. And Kepler's third law, which he called the law of harmonies, or the law of periods, shows us a mathematical relationship between the time it takes for the planets to go around the sun and their distances from the sun. And so with this law, we're able to make predictions about how long it takes for planets to go around the sun depending on how far they are from the sun. So let's talk about Newton's laws. One of his laws you can write as a formula, F equals ma. That's force equals mass times acceleration. Force is a description of the interactions between objects. Mass is a description of a body's resistance to changing motion. The more mass an object has, the more they resist changing their motion. And acceleration is that change in motion. So what this formula says is that in order for a body to change its motion, it requires an outside force. Without that outside force, an object cannot change its motion. It doesn't specify the type of motion that the object has. So an object can, if it's at rest, it can say at rest. If it's in motion, then it's going to be maintaining the same motion, meaning the same direction, same speed. His third law said that for every action, there's an equal and opposite reaction. So I push on the wall, and the wall pushes back with equal strength, but in the opposite direction. And that gave him a great insight into one of the fundamental forces out there in nature, gravity. Newton's theory of gravity is a consequence of his action-reaction law. He reasoned that if there was a force from Earth pulling apples down, then there must be a force from the apples pulling the Earth up, and that these two forces would have to be equal in strength. But this particular force is much too weak for something as big as the Earth to be affected. Nevertheless, gravity exists between any two bodies, but gravity becomes strongest when the bodies are massive and close together. From this idea, he was able to work out that an orbit is simply an object falling towards the Earth, but moving so fast so that it follows the curvature of the Earth's surface, never touching the ground. Newton's laws are precise enough to send men to the moon and satellites beyond the solar system, but more than 200 years after Newton published his work, Albert Einstein would show that he had a way of not only describing what gravity was, but doing it more precisely than Newton could. Einstein's general theory of relativity from 1915 said that space and time are woven into a fabric he called space-time, and that gravity was just the warping of this fabric from massive objects. Therefore, bodies, including light, continue to follow the straightest possible lines in curved space-time created by the presence of massive objects. Einstein's theories unlocked other secrets that still leave us in the dark today. I encourage you to come visit us here at Winery Observatory, where you can explore the sky and reach for the stars. There's nothing more satisfying than getting a chance to look at these spectacular objects through the telescope with your own eyes. I'll never forget the first time I saw Saturn. It would forever change my worldview. Carl Sagan once said that astronomy is a humbling and character-building experience. We as humans have a desire to understand the world around us, to explore new frontiers, and to find meaning in it all. I believe astronomy holds the answers that we yearn to know. For more information about our facility and how to sign up for our weekly stargazing sessions, please visit our website, www.winery.edu, astronomy/stargazing. Hope to see you real soon. Thanks for stopping by.